Hello, everybody. If you're just joining, we're going to give it a minute and let people file in. Thank you so much for joining us today. All right, we'll let people file in as we go, but I will start to get us going. So good afternoon, and thanks so much for joining us today. Welcome to the 17th edition in our webinar series on the convergence of technology and wetland science. My name is Cameron Davis, and I am the business development representative here at Ecobot. So today's topic is efficiency tech for mitigation banking. We've got a great panel of experts with us today who will be introduced in just a few minutes. Once we kick things off, we're eager to have a two-way dialogue during the presentation. So down at the bottom of your Zoom window, you should see a Q&A button. Please use that to ask any questions that you'd like to have answered by our panel, and we'll field them directly at the end. We're recording the webinar, and everyone who registered will get a follow-up email later this week linking you to the video. So our host today is my colleague with nearly 2 decades of experience as a wetland scientist and also the co-founder and chief scientist at Ecobot, Jeremy Shavy. So I'll hand this off to Jeremy. Go ahead.
Thank you, Cameron, and thanks for kicking us off in a good way here. So again, welcome to those of you who are joining us again and have been a part of this webinar series for the last year and a half or so. And for those of you who this is your first time with us, welcome. We do these monthly, and this is part of our community give back in respect to science and how the changes that we are seeing in our industry can be more appropriately applied to help create better efficiency. So today's topic, of course, efficiency tech. So we're looking at some of the tools that are being utilized within the context of the mitigation banking industry, both for wetlands and streams. And I've got Nate and Robert joining me here today. I'll do a little introduction here in a moment. For those of you returning, know I like to start us off just bringing us back into perspective, why we do what we do. So one of my favorite authors from the 19th century, William Pollard, says those who initiate change will have a better opportunity to manage the change that is inevitable. One of the things that I think many of us are seeing in the 21st century is the movement of the utilization of technology and how technology also is shaping us as people and shaping some of our behaviors. So I believe it is critical that if we want to help steer the direction of where these inevitable changes are going, that we need to be a part of it. And so as a scientist, as engineers and geomorphologists in our panel today, we're excited to share with you a little bit about how we are utilizing tools and how we are helping to shape the tools so that the technologists, the software engineers can have a better understanding of how things interact between the natural world and the digital world and how they can inform one another and shape the things to come. So I'm going to introduce Nate and Robert here in a moment, and just a general synopsis, looking at what we're doing today, introductions. We're going to look at the critical role that tech is playing in mitigation banking and very briefly touch base into what some of those are. For those of you returning, a little bit of an update in terms of what has been happening at Ecobot in the last quarter or so. And then we're going to take a deep dive. Nate's going to take us on a nice walk through some of the utilization of the tech that they're using at Water and Land Solutions. And Robert's going to take us into a deeper dive into 2D hydraulic modeling, the importance of that in respect to mitigation planning. And then we'll have a very brief announcement for our webinar that will be coming up in December. Very excited for our next discussion there as well. And then we'll have time at the end for questions and answers. And if anyone has joined us late, just so you know, if you run your cursor down to the bottom of the screen, a little bar should come up. And in that bar, there are 2 places where you can comment. If you want to just make general comments, we suggest putting that into clicking on the chat tab. If you have questions that are technical questions, regulatory related, something to do with the software, the tech that we're talking about today, or anything that would be directed specifically and might make sense to share with the general community, please drop those questions in the tab that says Q&A. And then I will curate those as Nate and Robert are both speaking, and that will give people an opportunity to bring in things that they might seek some clarity on. So very, very brief high-level introduction. Nate and I met, we presented in the same symposia at the National Mitigation Banking Conference in Raleigh this year. A lot of synergy. Right off the bat, I was like, oh man, Nate, gotta have you on one of these webinars this fall or this winter, when people are starting to think about what sort of new tools they might be interested in working with going into 2022, or potentially how might they lean into what Water and Land Solutions might have to provide, both to the private, public, and government sectors. So Nate's the Vice President of Mitigation Services at Water and Land Solutions, and his background is in geomorphology. And so Nate, thanks for joining us today. Great to have you. And Nate introduced me to Robert. Robert, I just realized I spelled your name wrong. I'm sorry for that on that one. So Robert's a civil engineer, but he, in his words, he would prefer to be down on the water and in the mud instead of designing the bridges. So he's been a part of designing the organic side of things with any of the functional uplift that comes with mitigation banking. So, and Robert is not that far away. He's just up in Johnson City, so really close to us here in Asheville in the Southern Appalachian Mountains. So Robert, it's great to meet you, and also thank you for joining us today.
Great to meet you, and I'm glad to be here.
All right, functional uplift. One of the things that Nate and I have been talking about recently is going beyond the functional uplift, going beyond just have we been able to hold water for the minimum amount of time necessary in the year for wetland? Have we created enough functionality in a new stream or tributary, and how that then ties into the existing system? Because the functional lift that we gain in mitigation banking, while being really important, is just the base, is the platform upon which everything else builds. And ultimately, it's like, how are we creating how through functional lift or uplift, how are we gaining a true space in terms of conservation for the biology, for the aspects that we engage with in respect to humanity? It's really critical to touch the concept of, yes, we are mitigating the changes or potential loss of wetlands or streams, or any of the other types of mitigation banking when you're getting into such things as like carbon. And that's critical, but that's just checking off a box. The most important thing that I believe in, and I think that Nate and Robert would agree with me, and probably many of you here today, is what we're truly doing is we're creating space that is set aside in perpetuity to create a biological sanctuary to protect not only our human infrastructure, but to also promulgate the conservation of our natural heritage into the foreseeable future. So that said, I want to pivot, bring it out of the biological, if just for a moment, in respect to the role that tech is playing in respect to mitigation banking. I love this image of the night sky over the earth, really showing like this concentration of the growth of the human changes and impacts to our planet and what that means. And one of the beautiful, beautiful things that we have in the 21st century is we have an understanding now. We have an understanding of our responsibility and our capability with proper planning to adjust and make room and to continue to promulgate forward our natural resources. So one of the couple things I just want to check in here about, I've already kind of leaned into where things are going into the 21st century. The evolution and the growth of our artificial intelligence is inevitable. It's going to happen in our lifetime. It's going to be happening faster and faster over the next 5 years. A lot of the tech tools that we are going to be talking about today are essentially components that feed into that. And again, if we are helping to shape that, then we are helping to shape the way artificial intelligence will continue to read observations of the natural environment. And so in this is in regards to everything that we've already touched base. So I'm just going to slide to the next one and introduce a few of, from very high level, some of the items that we're going to be talking about, some of the tech tools that are very helpful in respect to the mitigation banking industry. So some of the things we're going to hear about today: Autodesk, AutoCAD, Civil 3D. We're going to see some examples of 2D hydraulic modeling. Bentley MicroStation is also another system that's really good for it, such as in this image on the right, where we can get an idea of what, once we have created a new environment, at least conceptually and from a design, how is that, what is the story that is told, what is the narration that's able to be told to potential stakeholders of what that might look and feel like. Of course, ArcGIS Pro being a critical component for especially the initial environmental due diligence, as well as post monitoring, being able to map and track what's going on. My company Ecobot also playing a really pivotal role in this context as well, in the data collection and the monitoring of sites. Civil Geo is also another great design tool in respect to mitigation, banking planning and design, and then also for the long-term monitoring, as well as the due diligence, satellite imagery, such as some of the things our partners at Upstream and Lens are working with. So what we're going to take a little bit deeper look into today, I'm going to do a very high-level brief intro to Ecobot, as again, I already spoke to. And then also Nate's going to be talking to us about what they're doing in Civil 3D. And then Robert's going to be pulling out some great 2D hydraulic modeling, I believe, in AutoCAD. So for those of you who are here for the first time, Ecobot is a software platform that is allowing people to do their monitoring and delineations in about half the time. It is an iOS application and a dashboard that functions on any computer system at the office or at home, allowing us to gather our regulatory data and produce reports much faster. Very excited for our partnerships and our customer base. What I think the thing that really stands out to me watching how Ecobot has grown over the last 3 years is noticing how much feedback we get from our customers that the utilization of Ecobot is easy, intuitive, and simple, and yet we're willing to listen and continue to polish and refine the platform so that it's even more usable for everyone. Some of our updates, we have a new version that actually is launched today. And part of that launch, we've beyond the 10 regional forms for the Army Corps of Engineers and being able to produce those reports, we've now incorporated also Florida's DEP 62340 form, which of course is critical for the delineation process now with the 404 being assumed for many of the waters in Florida. Also, we've updated the National Wetland Plant List based on the updates that came out in the earlier part of this month. We also now have a NRCS's landform as a lookup tool built into the application, and also another GNSS receiver that's Bluetooth enabled paired to Ecobot as well. So SX Blue now joins EOS and Trimble and Juniper amongst others. And so I'm just going to leave you with this last slide here, just showing utilization. I believe that earlier this week, we just surpassed 45,000 wetland sample points being recorded over the last 3 field seasons utilizing Ecobot. So just pretty excited about this. Pretty excited that an idea that I came up with way out in the forest has turned into something that is being utilized by so many people across the nation. So thank you to all of those of you who are early adopters, and super excited to hear about what's next. But getting into mitigation banking, I wanted to pass the ball over to Nate here. I thought these guys playing rugby in a wetland was an appropriate way to say, Nate, it is great to have you join us. And if you want to go ahead and take over the screen share, we're all looking forward to hearing from you.
Thank you, Jeremy. Let me click some buttons here. Excellent. Yeah, so I'm going to present just a kind of a high-level overview of, I don't know, call it our standard operating procedure at WLS, how we're surveying, designing streams, constructing them. And then I'll hand it over to Robert. He's going to dive in a little deeper into some of the science and math and show you some models, 2D hydraulic models in modeling software like SRH2D, and how we use the hydraulic models in AutoCAD then to help optimize the design and make decisions. And I think that'll be a good segment there to go from, again, my high level view of our operating procedures there. But let me hit this video. And if you guys went to the Mitigation Banking Conference, I'm actually showing the same presentation that I presented there, but we can go through and maybe dive in a little deeper from time to time here. So our designs are only as good as the data that we collect. And this is a point cloud with LiDAR, and every project I do anymore, the existing conditions are flown with LiDAR. It has just changed everything for me, for how we collect data, how good a data we can get, how precise it is, everything from ground terrain data to inventorying trees. And then this is showing sonar getting bathymetry. So LiDAR doesn't penetrate water. So we have to supplement that with other forms of surveying, whether that be conventional, total station, survey grade GPS. And then we roll all that data in and we start running models. This is just a little video of a hydraulic model running, so we can see, we actually take the data. If we get a good enough survey, then we can roll the water through that survey and get a really accurate representation of what's going on. What's the inundation, the depth, the velocity, the shear stress. This is showing just particle tracing, maybe where sediment's going to go. And we've validated this stuff. It is, if you collect the data properly, you get a very good model that is representative of nature. And then rolling into AutoCAD. This is a passion of mine here. I've been working for years now to develop tools and create a way to design streams in AutoCAD. And AutoCAD is not set up for that intuitively. It's set up for roads or buildings and more structural type engineering. But if you take a road and you turn it upside down, you kind of have a stream. So it's pretty much what we did here. Using corridors, assemblies, custom coding those assemblies for facet slopes for the riffles, runs, pools, glides, inner berms. We can accurately design streams in AutoCAD. And it's the nice thing about AutoCAD is everything's dynamically linked. I mean, this is just, what I'm doing here is in this live demo on this screen is how fast it is. And we can go through, cut sections really fast, profiles. We can make changes on the fly. If we turn in a a permit, agencies want changes. Well, we can do that. And if we make a change to the bankable area, it updates the profile and the cross sections and the floodplain, everything adjusts and it's all dynamic. And then from AutoCAD nowadays with survey grade GPS and machine control construction, which is what we're showing here, we can take the flash drive right out of the laptop, save the CAD file and put it right into the machine. And this contractor is building from the CAD drawing right now. He's got sensors on his bucket that then talk to the GPS, which is up on the cab of the truck. And it's giving him survey grade centimeter accuracy on the end of his bucket there on the teeth. And so this, again, we're eliminating errors by doing it this way. We're optimizing efficiency, and we're able to do so much more restoration in such a short amount of time. It's really just changed the game for us, being able to take that technology and roll it into stream restoration, kind of catch up with the civil engineering practice, to be honest with you, so that we can get more. My goal, my life goal, is to get more stream restoration in the ground in the time that I have. So that's what I'm doing. This is a project in Colorado, and drones have again been like such a big help. Getting existing condition photography like this or videos. Every job I fly or every job I do, we're flying new ortho photos. We're flying videos of existing conditions. This project's just starting. I haven't constructed it yet, but when we do, we'll do the same thing and we'll fly through and we'll be able to see the changes and the functional uplift that Jeremy's talking about. I think this project, we're raising groundwater. We're gonna have a much more lush riparian area, and you're gonna see that in the video. You're gonna see a lot more green once we're done with this project. And of course, you can see all the erosion and different anthropogenic disturbance that the landowner's done. He's actually tried to do his own type of restoration here by putting in these dams and backing up the water, which has kind of raised the groundwater table. But there's a lot of improvements we can do to make it a sustainable system out there. And his impoundments blow out frequently. But yeah, so the drone technology, again, is just getting better and better. DJI, that's what we're flying right here. It's like they have a Maverick 3 out now. That's pretty cool. We actually, on this particular site, we learned a lesson. We flew LiDAR with a payload of 15 pounds, and that LiDAR unit crashed with about $500,000 of equipment on it. So it was a yard sale. I mean, it was the first time that's ever happened to us, and it came right out of the sky because the air was thin. This is at 9,000 feet, and the drone was probably up closer to 10,000. And the drone crashed, and thank God for insurance. But yeah, so we learned our lesson on that one. This is actually Civil Environmental Consultants, one of our contractors, and where Robert and I used to work. They're the ones that flew this site, and they've now got a much better drone and technology out there so that it can fly at higher elevations in thinner air without, crashing. But yeah, this is again, the drone technology has really changed the game. We still have to have boots on the ground. We still have to verify on the ground. So Robert and I were out there surveying the site just recently, getting bathymetry, break lines for the stream channel using survey grade GPS. This being an open site in a big valley, that worked out really well. But I can't say enough about using robotic total stations. Like in West Virginia, we don't even really go with the GPS because of the tight valleys and all the tree cover. We just get out the total stations and we're able to slam and jam with those robots. So that's something else I could talk about if anybody has any questions. But yeah, so just checking out anthropogenic disturbance here. And these are actually great images to use with regulatory agencies as well. We're doing more and more webinars with IRT meetings, and without the videos, it really is hard to explain what we want to do. And then when I came into the mitigation banking world, I started meeting with a lot more landowners and explaining what we're doing to landowners. So this is using AutoCAD InfraWorks. So this is a conceptual design for that site we just flew. And it's just a picture, it's just a rendering that's totally conceptual, but it gives a landowner an idea of how we're going to transform their property and what we're going to do. I talk about the goals and objectives, but can you really show it? And can that landowner in this case, can they visualize what it's going to look like? so this has been pretty helpful in order to get landowners on board and tell them what restoration is going to look like. The idea of planting more trees, more water, and a greener site. What wetlands kind of might look like. And so this is the kind of stuff that we're presenting to landowners in order to get them on board. And without the data, without the LiDAR, the AutoCAD, the modeling, you can't really produce this stuff accurately and give them a good representation. This is a real design right here. Like everything that's laid out there was designed, this grading plan in AutoCAD, and then we painted in all the plants and the fence. And this landowner wanted corridors for the elk to travel through, so that's what I was showing back there. This is stepping in a little bit more into Robert's world right here, but looking at shear stress. And so this is the design overlaid on the existing conditions, showing the different colors are shear stress. So red is a higher shear. Actually, this might be inundation. I take it back. This is inundation. So red is deeper water, blue is shallower water. You can see where we've got like little wetland cells here and there, like old oxbows. This is also helpful in communicating with the landowner. And then if we go cross country into Pennsylvania, we're doing a lot different type of restoration in PA, different than I was actually used to. So this project here will be a floodplain legacy sediment removal project. And so we can apply the technology very similarly to different types of restoration. Within AutoCAD, what we'll do is we'll do like a Roskin Priority 2 restoration where we cut the sediment out of the floodplain that's considered to be legacy sediment from agricultural use in the valley, as well as old mill dams and stuff that you see in Pennsylvania, and getting down to a kind of a prehistoric sediment layer, a gravel layer that's underneath the legacy sediment. That's the idea here. But yeah, this site, again, flying the LiDAR or the videos here of existing condition. We also did LiDAR out there and making modifications to a lot of these driveways and stuff with the landowners. This was really helpful to talk about how we're going to put in floodplain culverts and different things to stop contraction scour. Yeah, so again, the drone technology here, just helping out with communication with the agencies, with the landowners. We did IRT meetings for mitigation banking instrument and the prospectus, showed some videos. I actually got feedback from some of the agencies that when they looked at it on paper, they said, well, that road's too close and I don't know if this will be a good project. And then I showed them a video of it and they said, oh no, you got tons of room out there. So it was, again, really, really helpful to run the videos. And I know a lot of people were doing this, and I'll mention that to do it legally, commercially, you do have to get a license from FAA. So Robert and I are drone pilots, which sounds kind of funny, but we do have an FAA license to fly drones. So that's something you might want to consider if you're flying drones and you're getting more and more into the aerial mapping component of projects. You can look into that Part 107 drone license. So, but yeah, definitely, and there's a lot into it. I'll just dive into that for just a second. When you're looking at what to fly, you really have to do your homework before you go to the site. I mentioned about elevation and how the drone crashed because it was too high of an elevation. There's also airports nearby. The commercial drone, or the drones you can buy at the store, they'll actually block. They won't fly into no-fly zones. They're programmed like that, but it's good to know where those areas are. I was working near a hospital, and there was a helicopter coming in to the hospital, an evac. And so we actually, definitely brought the drone down and stopped what we were doing because of that. So those are things you learn when you take the drone test. And this is a comparison here of existing conditions and proposed conditions and inundation. Again, Robert's going to kind of dive into this a little bit deeper here in just a minute, but this is that same site that I just showed you on the video with the drone. And this is how we overlay that video with actual data that's produced from the grading plan from AutoCAD, and then the surfaces. This was done in HEC-RAS to get the inundation and where the water's going. And this was used mostly for the agencies to review. There's a QR code right on our plan set, so you can just use your phone and open up this video right off the plan set and play it. And that's, again, for agency review. I can't speak highly enough of that. But those are just a few things and a quick little introduction there on some tools, some technology, some things to consider that have been really helpful for me and Water and Land Solutions. And I'm going to roll this right over here to Robert. Let me get out of this screen. Stop share. And I will hand this to Robert to get into a little bit more of the science and some live demo. Take it away, Robert. You're still muted, dude.
All right. So like Nate said, I'm going to talk about 2D hydraulic modeling and as it pertains to mitigation banking. So essentially, we use 2D hydraulic modeling to optimize structure placement, identify hotspots, reduce cost, reduce exposure to risk, but also the outputs of this are used as a communication tool for landowners, stakeholders, regulatory bodies, and a number of other folks. We typically use SRH2D or HEC-RAS 2D. Today, I'm going to talk about SRH2D because it's the modeling software I prefer. I like it better because it has a mobile bed component as well as its interface is more set up like ArcGIS and stuff. I find it more familiar and easier, just easier and faster to use. But really, regardless of what type of 2D hydraulic model, at the end of the day, most people, what they want is a pretty picture. What you need to do to run any 2D hydraulic model is really only three things. And those are, you're going to need a mesh that contains your surface geometry. You're going to need something that defines flow resistance, which is typically a Manning's N, and then boundary conditions. Your boundary conditions are going to be inflow at the upstream end, so a flow rate, and typically a water surface elevation or something that defines your downstream boundary conditions. And so once you get those three things, it's all pretty easy from there. Trick is just getting those three things. So the first thing that we get is a proposed surface, and we get this from AutoCAD. So Nate mentioned 3D design tools. All of our designs are being done in 3 dimensions. That surface is then pasted into the existing surface, which you're seeing here in the kind of light pale lines. That creates the surface geometry that you'll need for your mesh. And then you'll need to define what area you're wanting to model. So in this case, this kind of white line that's it basically defines or covers the valley bottom is the area of interest. So it's the area I want to model. And so a lot of the stuff that we use for modeling, regardless of which software is generated in, it's either CAD or GIS or another software imported in. And so you'll import this data into in this case, SRH2D. What you're seeing here is contours created by the scatter data. That's the exported data from CAD. And CAD just exports a land XML, which is essentially a point cloud. If you're doing existing conditions, you can directly pull in the LiDAR data. So then you need to create a mesh. And so a mesh is essentially defines how the model is going to solve the Navier-Stokes equations or the depth average 2D Navier-Stokes equations, which is continuity and conservation of momentum. And so essentially this model, it's Creek Run Branch that I modeled when I was back at CEC. But essentially the model is going to do a computation on each one of these cells. And if you zoom way out, you'll see that you can't even see the cells. There's so many of them. You'll see in this case, we refined the model basically along the flow path, so the belt width of the channel get higher resolution. And in the extremities of our model boundary, we have larger cell size. That makes your model a little more computationally efficient. In this model, it's purely rectilinear cells, all of the same cell size, which generates more data points, takes longer, but it's faster for me to set up. So once we've created our mesh, which basically we just pulled in the mesh boundary that I showed you that defined the area I want to model. In this case, I'm keeping it all rectilinear elements. So that means they're all going to be basically rectangles in shape. So they're all basically parallelograms. We've got that. A Manning's N. With Manning's N, we'll typically take that from a land use cover from GIS and define thick woods. You can imagine a mowed field has a less resistance to flow, and you can really get into great detail with how you map that. When I'm doing a project, I typically, my Manning's N is going to be very simple, and I'm really just going to look at one, maybe two types. And oftentimes I'll do a single Manning's N for the entire project, because rather than see how trees out there affect the flow field, I want to see how my grading is going to affect the flow field. Now, if you're doing something for like water surface elevations for FEMA, then you're going to go into more detail about how you handle your Manning's N. Then we have boundary conditions. So if we go, in this case, we'll turn off the world imagery. So upstream, we have something called an inlet Q. And that's just inflow. And so you can just assign a boundary condition. In this case, I did a constant boundary condition, 460 CFS. You can do these as a time series. So if you have a hydrograph and wanted to run that through, here I'm looking at recurrence intervals. So the 1 year, the 5 year, 10 year, 100 year. And then I'll put water in basically at each tributary. I'll have an inlet. And then at the downstream boundary condition and the exit age. In this, I did a stage discharge relationship from a different hydraulic modeling software as HY8, because there's a bridge. And I stopped the model at the bridge, but that bridge is going to control the water surface elevation. And so if we click on that, you'll see you assign a boundary condition, and you're going to be looking at a curve similar to this, depending on what your boundary condition is. So we'll see that as your water surface increases, so does discharge. Here you're hitting the bottom of your bridge deck, so the water surface comes up a lot without increasing your discharge past that point much. Once you overtop, we go back to more typical type curve. So like I said, the three things you have to have are a mesh, which defines your surface geometry and the continuity between for the equations of motion. Manning's N, and then boundary conditions disclosed. I also use monitor lines a lot, or monitor points. Not necessary, but if you ever have actual data on floods and you want to calibrate your model, I verify Manning's N and things of that nature. You typically do that at discrete monitoring points where you have a gauge. Once you have that, you build your model. You put all those three elements into your model. And this year, I've got a 50-year flow event, got a mesh generator, Manning's N, boundary conditions, and then monitor lines so I can keep up with where water's at in the model. So you'll run that. And then the model will, in this case, it's going to export a bunch of text files. So this is, for example, the 2-year flow. And when you pull this up, you're going to see a line of columns. You have a point ID, X, a Y, and then the rest of the columns are all various Z values that the model outputs. It could be water surface elevation, shear stress, velocity, magnitude, X, Y, direction, velocity, and that does that for every one of those mesh elements, which in this case is just over 300,000 mesh. And so in order to pull that data into most anything and use it, you're going to need an X, Y, and Z format. So most of the people I know who run models have some type of code that processes this. And this seems clunky, but it wasn't. But a number of years ago, we were still using DOS prompts to get models running instead of the GUI interfaces that you're seeing in today's model. But it's really the post-processing and data analysis is where the meat and potatoes of 2D hydraulic modeling is. Setting one up is going to be faster than a 1D model. Running it's going to take longer, but the data processing, you're getting so much more data to look at that is pretty intensive on data processing. And so what you're seeing now is that code, it's just spitting out a wide range of outputs. So it's basically just parsing that data down to values I'm interested in, which are depth, shear stress, stream power. I got a unit Q, so I start calculating some things beyond what the model does that it may be variables of interest. And unit Q is just depth times velocity. And when you start looking at that, you're starting to see where's your magnitude of flow going. If you have secondary flow features because you have a side channel for juvenile rearing habitat, but you don't want it still in 50% of your flow at the 5-year event, we'll run it through there, look at the unit Q and see that. So the code just kind of runs, does its thing, and then in CAD, it's just like building a surface. It's an X, a Y, and a Z. So we'll open up a CAD template that we created. It has a legend for a heat map. That's this legend's actually for its Roskin particle size entrainment. So it takes shear stress, calculates your maximum mobile particle diameter. We'll use this for sizing the ripple substrate. But to create a surface, you'll just go to the definition. We just created point files by running the code. And so in this case, I think I want to look at 5-year depth, let's say. We pull it in. It's ENZ for easting, northing, and elevation. That's the same thing as X, Y, and Z. And remember, each of those columns with its own Z value. Takes that half a second to build. And then we'll zoom to it. And so we have a depth at the 5-year flow. Red's going to be deeper, blue's going to be shallower. And right there is one of the first things you'll use for creating figures. So then we start using some of the other technology that created background photos. So in this case, we have at a 45-degree angle, we have now on the upper right, we have the proposed condition, and then we have existing conditions under a bank full discharge. So approximately a 1.5-year recurrence interval event. We see that the stream's confined to its channel in the existing conditions. and then it's overbank out of its channel during the proposed condition. And that's one of the things you can use to start saying, where's water getting out? What flow rate does it come out at? And that's well and good for that purpose. But in general, for reducing risk, the thing we look at, and I think most engineers look at, is going to be shear stress. So here I've got a structures file, and you'll see, like say this straightaway here, we have what's called a log riffle. And then this one, we didn't do any log riffle. I didn't really feel like the need for grade control. And so what we did was we'll XRF in our shear stress, reload that. And remember, pretty much anytime you're looking at 2D hydraulic model results, they're going to be displayed as a heat map form, where blue is low shear stress or low values and red is high value. So on the right, this riffle, and this is the same stream, same discharge, this riffle's hot, it's red. And that's not necessarily bad. It just means that there's higher energy for more erosion. So we're going to place our log riffles here. And as everybody in the business knows, you have to take out some trees when you do stream restoration. It's kind of like making an omelet. You got to crack an egg. But we want to use those eggs. We want to use those trees in the stream to uplift ecology and basically make a better product without being wasteful of our resources. So in this case, we didn't feel like we needed to be as heavy. So we didn't use those trees. We also didn't have, you'll see grade control structures going into this pool in the same way we did here, but you'll also see we're getting red and pretty hot, and it's showing us that your higher risk of erosion. So we're managing our risk by doing that. We're using our resources more efficiently, and then we're increasing the diversity of habitat because we have a slightly different riffle habitat here than we do here. And so that's how we make some of the decisions that we make in terms of optimizing design and using the resources that we have at our disposal. If we'll switch over. So here's a same design. And I put this design in here because this was an earlier iteration on this project. But what we're showing here is that unit discharge, depth, time, velocity. So it's refresh. ISS problem with doing some of these things live is that technology won't cooperate with you. Well, bottom line is what we're seeing in this model was we relocated the channel using priority 1 restoration, and a large volume of the water was being captured by the old channel. And that was for a number of reasons. When I looked back through at our surface, we saw that the fill in the old channel was left low. And one of the things I like to tell people about hydraulic modeling is it never tells you anything you don't know, but it'll certainly point out things that you knew and you missed during the design process. So that was one of those examples where we had a lot of flow coming through the old channel. It was showing up as brighter colors, and that would give us some reason to look back at our surface and think, should we change this? And in this case, we did, and we went to a redesign. And then that was a kind of a single thread, traditional natural channel design type approach used down there. On this, we have a much more anastomosing, multi-channel type system. And the existing conditions in this location, this was actually below mine spoil. And so you'll see this bench located here. Is all a contour mine. And as they splay sediment off the side of the hill, it runs down, and all this kind of droopy, funny looking contours are in fact landslides coming off the mountain. And so this area has graded, but during that aggradation, so it degraded, then it started to down cut, and you have all these head cuts ripping through this valley, a lot of delineation with stream. And the conversation with this IRT was that they wanted to keep that morphology, but restored the actual channel morphology. So you had kind of a multi-thread system without having the head cuts and loss of groundwater. That was a little bit different, and that's what a system like that showed up looking like on the hydraulic. How are we doing on time, Jeremy?
We should probably wrap up on this in case we've got any questions from anybody in the audience, if you want to kind of walk us out.
All right, that sounds great. I was going to send it to another video, but Nate showed those. And I think we can go to questions. We can always show more pretty pictures if anybody wants to see them.
Great. Thank you, Robert. Super informative, super granular. I really enjoy being able to have presentations like this at times that really help enumerate what it is that getting into in a deeper granularity there. So just to jump in here for our next webinar is December 8th. We're going to be joined by Greg Sarenbetz from EPA and Megan Lang from U.S. Fish and Wildlife. So we're going to get our annual updates and where the future of NWI mapper data sets, and also what's happening with the National Wetlands Condition Assessment updates from this year as well. So please join us again before we all disappear for the holidays for weeks. Love to see you there. So just want to thank everybody. Look at that, Robert. While you were talking, I changed the spelling.
Thank you.
Yeah, great to have you guys both on. So right now I'm not seeing a lot of questions coming from the audience, but I did have a few things that I jotted down that I'm interested, in directing towards both of you. So one of the things that I'm really interested in, Robert, is in context of your 2D models that you are creating. One of the things that we're starting to get headway on is where, like augmented reality, being able to see, like put on a virtual lens and go out and you can kind of see where some of these designs might lay out in the field. But then the same thing comes into play when we're collecting data. Something, Nate, that you spoke into early on. Design can only be as good as the data collected. I mean, I love that. That could be like your byline. Maybe it is. But really stands out to me. So thinking in terms of these models, especially these 2D models that you're looking at, Robert, is it really easy? So if I'm out there collecting a bunch of wetland related or stream related data, can I really easily send you those shape files and pull those into your model so that then it can then also inform what Nate's doing in Civil 3D?
Yes, so we can pull those shape files in quite easily. But once I have the model, once I have the surface information, say you're talking about the augmented reality type glasses, well, it's just a point file that it pops out the same way you're getting your LiDAR data. So that water surface, water velocity, you could put those goggles on have your wetland data sitting there in augmented reality with the water surface elevation or water depth at the 5-year event or whichever event you pick. And you could see that with augmented reality. What I'd like to see is be able to put those on and then have Nate design the stream going down through there and the water change and interact with the wetlands and things like that.
Yeah, that sounds great. Yeah, it's many people often will refer to a picture says 1,000 words, and that's one thing, Nate, that really stood out to me when you made your presentation at NMEBC. It's just like doing a flyover with a drone is great. It gives us an idea of existing conditions, but then to overlap design and be able to walk your stakeholders, walk your really your clients through the process of what something is going to look like. I mean, a better narration tells a far greater story. So Nate, I'm wondering if you can lean into that. Like, how has that helped with your stakeholder conversations, your contingency plans and meeting with people boots on the ground and helping get projects rolling? How has that helped you?
Yeah, no, that's the name of the game, really. There's been a handful of projects, I don't think, like that one in Colorado I was showing, without those tools and doing all that extra work, we would have never got an option signed by that landowner to work on his project, or his property, because we're talking about a billionaire from Texas that owns 250,000 acres. What does he need us? If you don't show the improvement to the property, the money is nothing to him. So it was really important there to say, hey, look, we're improving your property. This is how, and we're talking about a very educated landowner as well. He was trying to raise groundwater. He was trying to restore that valley that had been disturbed over years of farming and mining and forest fires. But he can only go so far with it, with putting in check dams and ponds, right? So I gave him a little education, showed him what, with the InfraWorks video, showed him like what could be accomplished, and overlaid those existing and proposed conditions. And he said, okay, well, I think that looks pretty good. So
I imagine he's probably a hunter and a nature lover to be able to slide in some of the moose crossing and stuff like that,
Right. Yeah, no, and actually he does guided elk hunting on that property, which is like $10,000 a person. So
wow,
big part of it.
Yeah, I know. I think I remember from the video in Raleigh that when you played it, there was actually a scene in there where there was an elk somewhere in a wetland or something like that. I don't think that came through, at least not on my side today. It may have glitched out for a moment there, but
Right.
yes, I mean, pictures really help us. And so I think, that's what I'm really seeing in general with this entire industry, being able to draw up data from what exists on the ground in the field, and then to be able to retell a story of what it could look like.
Mm-hmm. I do see a question there, Jeremy, from Bill about LiDAR and iPhone 12.
Oh, okay. Let's see that LiDAR. Let's see.
Could be used
The
as a
reason a
simple-
LiDAR function in iPhone could not be used as a simple rangefinder in the field. That would be convenient.
Yeah, I'm not familiar with that application with the iPhone 12, but
Yeah.
a lot of this stuff, I use my phone all the time with actually just like as a GPS in the field anymore. I can take the 3D files from like Robert was showing you. I can actually put them on my phone and use them in like Google Earth and different apps out in the
Okay.
field. It's actually pretty accurate.
Yeah,
super
I'm doing
impressed.
something similar with Esri's field maps. So I'll take my base models and then export it, as a file package, and then I'm able to, look at that right in the field. All right, here's where things are lining up. So I'm going to focus more of my time on this particular area because that's where the impacts may be, or that's where we may be tying in to existing stream or wetland systems.
Right.
Yeah, it's really exciting where things have come. I'm going to pause for a second. It's 1:30 right now. So if anybody needs to leave, thanks for joining us. Please join us again on December 8th for the NWI and NWCA updates. If you don't mind sticking around for a couple more minutes, I do have one more question in respect to some tech that you spoke into, Nate, that I'm not as familiar with. You talked about the robotic total stations. And I was wondering if you even actually spoke into that a little bit. Would you mind sharing with us a little bit about what those are and what data you are gathering?
Yeah, no, that's so, existing conditions, terrain data, topo data. That's what we're using the LiDAR for. That's what we're using the survey grade GPS and then conventional total station. Now the robots, that's something I've been using for years now. But the really the beauty of the robotic total station is you don't need two people. You can do it with one person. And the gun, you have a tripod set up, but it'll follow you and track you as you walk around. So you have the survey rod and the data collector in your hand, and it's talking, and you can get, I don't know, half a mile away from the thing, and it still communicates. But yeah, it's line of sight, so you have to still traverse with it.
Okay.
But it's actually I find it faster than survey grade GPS when you're in thick canopy or tight valleys. And I don't even bother with the GPS going into that kind of terrain. I mean,
yeah, especially in the summer, right? You got thick canopy cover.
Yeah, I mean, there's a lot of places, I guess, North Carolina, like Coastal Plain, that GPS would work great. Right. But, you get in around Asheville and you're in the mountains. Well, I mean, sure you guys find out that GPS is hit and miss. And so, yeah, that's when we bring out the robotic total stations. Again, you can do it with one person. Robert and I have done this a number of times where, he goes over to this stream and I go over to the other, and we just slam and jam and meet in the middle. So yeah, that's or meet at the ends where they come together. So we're able to hammer down pretty quick with those robotic total stations, and they actually use those with the machine control construction as well. So if the machine can't get GPS, they'll use what's called LPS, which is running off of the robotic total station, which works, again, just as good, just as accurate, and you don't have to have signal to the sky.
Okay. So one other thing that both of you guys spoke into a little bit, and we've talked about on the phone a little bit as well, is the utilization of drones for gathering data. You guys did a great job leaning into that today. We have not actually had a drone webinar in probably 9 or 10 months. And so I'm wondering if there's any FAA rule updates that either of you would be willing to share, if there are any from in the last year. I'm not aware of any, but I just thought I'd serve that up as, in terms of the rigmarole. Robert looks like he's got something.
It seems like those are always updating. I always talk with my buddies that keep up with that better than I do.
Yeah, so you have anything to bestow upon us, Robert? Any changes in the last year?
Not that I can remember. I'm sure there has been.
Other than don't put 15 pounds of gear on the bottom of one up at 9,000 feet elevation?
Yes, definitely don't do that.
Yeah, well, quite the story. So, well, good. Well, Robert, Nate, really appreciate you guys taking some time out of your busy schedules to do this. I know when we were talking a couple of weeks ago, we were all running around with our heads cut off trying to take care of sites before the end of field season. And so certainly appreciate you taking the time to jump on with us here today. Look forward to seeing you both at either the Stream Conference or NNBC this coming year. And yeah, again, thank you so much for your time. And Nate, do you want to make any closing remarks before we sign out?
I appreciate everybody's time. Thanks for listening to us speak out about stream restoration. And yeah, that was a good dialogue there. Thank you.
Sounds good. Robert, anything you want to throw out before we close out?
I'll just second Nate's opinion. Thanks for joining us, and it was glad to talk about streams.
Great. And if anybody would like to reach out to Nate or Robert or myself, the landing page when you first registered, there's all the links you need to find us on LinkedIn. You can also contact us directly in respect to if you want an email or if you have conversations that make sense on the business side of things. So Nate, Robert, thank you again so much. And I'll look forward to seeing you guys sometime in 2022.
All right.
You
Thanks, all.
too.
All right, take care, you guys.
Goodbye.
Bye. Thanks for joining us, everyone.